All right, so this is a screencast on how to finish up the CPO Roller Coaster Lab. And what we're going to have here, you'll have all this data filled out from your lab. And what we need to do is take this data and calculate the kinetic energy and potential energy of the marble. Now we're going to do this in millijoules this time instead of joules, and I think that's easier just because it's going to give us a number that we can graph. Otherwise, we'd have these really small numbers, and I don't think it would be that fun to graph. So we're going to do millijoules, and it'll make things a lot easier. So what we need to do is we need to calculate the kinetic energy. So let's go to the equation first. So you need kinetic energy equals 1/2 mass times velocity squared. So we have that our 1/2 in decimal form is 0.5. We're going to multiply that by the mass of the ball, which in this case it said it was 5.4 grams. And then we're going to multiply that by the velocity that it was traveling. And I calculated mine, realized yours might be different, 0.25 meters per second. And I need to square that number. So there's my velocity squared. Now notice that in the past we've changed the grams into kilograms to get the unit in joules, but this time we're just going to go ahead and leave it in grams. That way it'll calculate it in millijoules and it'll be easier to graph. So it's okay to leave it this time. And let's go. So when you do the math here, 0.25 times 0.25, that's going to give you, let's see, it's going to give you 0.0625. So I come down here, 0.0625, and then the units associated with this, remember, a meter over a second. When you multiply a meter over a second, that gives you meters squared per second squared. All right, so that's the same thing here. A meter times a meter is a meter squared, and a second times a second is a second squared. So there we have our units squared away. We now multiply that by 5.4, and then you multiply that by 0.5. We got our grams here and 0.5. So now all you'll do is run the math. When you do all that, you should get a value. Let me do that real quick. Of 0.017. I'm going to round here. 0.17 grams times meters squared per second squared. And because it's still in grams, that is going to be the same thing as if I converted it into a kilogram and went back. That's going to give me my answer in millijoules. All right. So essentially I have 0.17 millijoules. So that's not very much energy. And that's what's going to be recorded in my table right here where it says kinetic energy in millijoules. Now I need to calculate my potential energy. So now we need the equation for that. And potential energy equals mgh, or mass times the force of gravity times the height. And once again, the mass, we're going to keep it in grams. So it's going to be 5.4 grams for the ball. We're going to multiply it by the acceleration due to gravity, which is 9.8 meters per second squared. Remember, that's a number you just need to know, a constant on Earth, times the height of the ball. And in my case, I got off the data table 0.27 meters. All right, so now it's just a matter of multiplying all those across. And that gives me 14.28. 14.28. And once again, that's grams times meters squared per second squared. Notice that because a meter times a meter, that's going to give me meters squared. and then it's over seconds squared, and then I have my gram. And in order to, just to save us some conversions, some calculating, that answer is going to give it to me in millijoules. So that's going to be how many millijoules of energy I have. All right, and that's what you do for the rest of them. You just go, then you'll calculate and find the kinetic energy of 2 and of potential energy of position 2, and do that for all of them using your data up here in the data table. Then you're going to get to your graph. All right, so here's where you're going to be graphing your information. Make sure that you use your graphing checklist to make sure you don't forget anything. But essentially, when we do that, a couple of things. You're going to have your y-axis and your x-axis. Remember, the independent variable, the thing you decide to change, is on the x-axis. In this case, we're going to call that position. And we're just going to go with positions 1 through 7. We could give them actual values as far as centimeters, but we're not going to do that. We're just going to call it position 1, 2, 3, 4, 5, 6, 7. So because of that, you'll want to make sure that you use a good portion of the graph. So you might have to skip some lines in between each one. And then our y-axis, right, that's going to be the amount of energy. So we're going to write that down as energy. And the units in this case are going to be millijoules, isn't it? All right. And then we're going to have our amount of millijoules. And you'll just need to make sure, like, let's say that you have a maximum of 20 millijoules. So make sure that your 20 is somewhere up near the top of your graph. Then you're going to be graphing both the kinetic energy, all right, and the potential energy. So as you go through, let's say that you get something like this for the kinetic energy. Go ahead and use a nice kind of curved line to connect the dots. And then remember, you're going to need to do a key, and because you're going to also have another line for potential energy. And let's say you go through and you get your values for potential energy. And so then it's going to have its line. So remember, over here, you're going to need to make a legend that tells us that the red line represents either kinetic or potential, or whatever color you choose to use, and the black line represents potential energy, or kinetic energy. All right. So when you do that, you should have a pretty cool graph to take a look at and see about the relationship between potential and kinetic energy.